All right, this is Dr. Carroll. We're going to talk about the three main object-oriented programming principles. Okay, I've already started filling out a little bit of what they are here. In case you didn't remember, they're encapsulation, inheritance, and polymorphism. So let's talk about each one of those separately. So encapsulation, what does that mean? Well, if you look at the word, it means to encapsulate, to put something in a capsule. You can imagine a barrier being put around something to protect it, something to keep everything together, to put it in a capsule, to encapsulate it. So what are we putting together? We put, yes, I really want to edit it, put data and methods together in an object. Okay, so when we're talking about object-oriented programming, we're going to put the data and the methods, we're going to encapsulate them together in the same object. And so what the user sees, and only what the user sees, hold on, I'm fighting it. Okay, yes, I really want that. Okay, thank you. Users only see the interface. Now, what do I mean by an interface? I like to think of an ATM. Do you know what the internals, the implementation of ATM are? Well, probably not. But you know what the interface is. You got a screen, you got a keypad, you got a little security camera, and you've got the cash dispenser. That one's the important one. And different things like that. That's the interface. You don't know what's behind in the wall there, what's going on, if it's some monkey reading the things or if it's all digital. We don't know that. What we see is the interface. And so in terms of object-oriented programming, the interface is the methods we can call. What is public? What can we get at? Another way to think about that is the inputs and the outputs. That does not include the implementation details. So encapsulation is critical to building large projects. And that's so that people can work independently and know, okay, we're going to start out, we haven't implemented it yet, but we know what the interface is going to look like. And you can design to that, one group talking to another. Large projects. Now, remember that the greatest cost in software development is maintenance. Maintenance. So if you have well encapsulated components, they're generally easier to maintain, which means less cost, and that's very important. Encapsulation is implemented in C++ with classes. So why then do we have encapsulation? Let me just enumerate some of the points. It creates modular programs, which is very important. Hopefully that's a principle that you've come to believe in. It allows for code reuse. Very important concept. Sometimes you get caught up in working on assignments, you don't see that as much, but when you start to work more in the same area, you'll say, hey, I've already done something very similar. Let me reuse that. And it'll save you lots of time, in part because you've already debugged the code and you know that it works flawlessly. It provides data security. It also supports team programming. Allows you to say, hey, here's the inputs and outputs, and we haven't designed the implementation yet, but we'll work on that. And another team will say, okay, great, we'll design to your inputs and outputs, and then we can make progress while you're making progress and do it in parallel. It's easier to maintain, as talked about before, and it lowers software development costs, which is important, of course. So let's talk about the three encapsulation practical rules. Okay, so there's three. The first one is to never put data in the public interface. So if we're not going to put it in public, where are we going to put it? The private interface, or maybe protected. The second is to create accessor methods for each data member in a class. You can think accessor methods, getters, setters. The third rule is keep helper methods. These are methods that deal very closely with the implementation details. They may even give away some of the implementation details in their name. For example, initialize 2D array or something like that. That would not be appropriate in the public interface, but is certainly appropriate to help your code be modular and reuse codes within a class. So keep helper methods out of the public interface as well, so that you can hide the implementation details. And that's encapsulation. Let's talk about inheritance. I have a couple of kids, and I've been surprised how many times people have come up to my wife and me and say, "Hey, they look like you." Well, they do. There's a reason for that. And they've inherited some of my attributes, physically at least, and some of them good, some of them we're working on. So what does that mean for encode and inheritance? What it means is that we can create a new type that is as an extension of an existing type. And so we derive a new class from an existing class. The derived class inherits the attributes and behavior of the base class or parent class. And what this does is it helps to reuse code in an extensible and intelligent manner. Now this video is not about inheritance, so we'll just leave it at that. Inheritance is great to organize objects in a very intelligent and extensible manner, which will make it so that you type less and save those precious keystrokes. Polymorphism. What is polymorphism? Well, before we get started, I want to issue a little challenge. This weekend, I want you to use it 3 times in a non-technical discussion. Let me know how that goes. So the word polymorphism actually means many forms. What does that mean in terms of code? Well, we can get into the situation with inheritance that the compiler doesn't know at runtime what method is actually to be executed, which is kind of cool if you think about it. So polymorphism allows this determination to be done at runtime of which method is to be run. And so it allows us to implement inheritance and do some cool things with it. Well, there is the 3 object-oriented principles. Great.